we'll go ahead and get started. So thank you everybody for joining today. Myself, Nick Miller, and Linda Garrity will be talking through 4 reasons why a scan to BIM strategy is essential and how you can achieve one. Really at a high level, we're going to, kind of talk through just a few key features with you here. We'll kind of run through the US CAD intro. We'll jump into what is laser scanning. We'll kind of talk about soft costs for project pursuits and visualizations. Do your as-built actually represent the existing conditions? How to minimize the RFIs on the back end of the project, and then what to do with the talent shortage that we have today. So very quickly, we'll run through the intros. I'm Nick Miller. I'm the Director of Production Services here at US CAD. I oversee all of the sales of our production services. And really my job is to kind of coordinate efforts between our clients and our internal production teams to help you guys get your projects done more efficiently, utilizing outsourced labor. And then we have Linda, who is the director of our reality capture department. She oversees all the hardware and software sales and really works with clients to understand their process today, where tools can supplement and work in that process and workflow to make their lives easier on a daily basis, with the focus being around reality capture solutions. So who is US CAD? We are your one-stop source for AEC technology solutions. So we take a very consultative approach, looking at companies, understanding how you work today, what you're looking to accomplish, and then figuring out what tools, software, hardware can kind of fill in the gaps, or retraining may apply to actually kind of get you guys to your goals, make you more efficient, and help you accomplish projects more efficiently. We focus on specialization. So you'll see there we have a very specific product line that we support. We are primarily focused on AEC. We do support a little bit of manufacturing, but essentially our entire business is aligned around the AEC industry. We do offer scalability and scaling and coverage. So it's something where, your teams are out there performing work every day. We do the same things in-house, so we can train you on how to do those things. We can help you do them and get them across the finish line. We can kind of jump in and assist you in whatever way you need. And then that commitment and connection, we absolutely are a company built on culture. We very much want our customers to be successful, and by default, our employees to be successful as well. So we really prioritize kind of connecting with your organization, understanding your goals, and really aligning ourselves with your business priorities. Services that we offer, we offer a lot of BIM consulting and implementation, training, education. We have dedicated project management teams. We do lots of VDC. We do lots of scanning to BIM, do production services. We're actually model and draft for our clients. We help clients with the digital twin solution. Here is just a quick overview of all the things we do, something you guys can read following the presentation when we send the deck out to everybody. With that being said, Linda, do you want to tell us a little bit about laser scanning?
Sure. You did so good, Nick. You're so hard to follow.
Hey, I try.
So, yeah. So for you guys, 3D scanning is just a digital technology that we use to digitally measure spaces for accuracy. So things that you can't see with your eyes, typically we can see through the data sets. So one of the things that's really important is to keep in mind is that, we have a multitude of devices, and they all capture data in different ways. So really understanding what you want to do, what do you need the data for, where does it need to go, those are all things that that help us to understand the right solution to provide for you guys. So anything can be scanned. It's a completely non-destructive technology, so we don't bore into any walls or do anything. They say that scanners only pick up line of sight. Well, that's true. However, if you scan the interior of a building and then you walk around and you scan the exterior of a building, you can pull that geometry together, and then you can actually slice through that building in kind of an MRI form. So we can see where things don't line up, and gives you a lot of insight into the building in a digital way. Then we can slice and dice as needed to use that information to help you guys make more informed decisions on the front end. So this is just some imagery in regards to these are step ups, clearly done prior to a concrete pour, bridges, things that you couldn't get close to without, scaffolding or, risk, right? So that's why we love it. I love the stairwell. It's one of my favorite things. It can just provide a lot of information to you guys to get your project started off on the right foot. So how do we figure out how to get you started off on the right foot? Well, we ask you a lot of questions. And so the person that really drives those conversations in our organization is Nick Miller. And so with that, let me give it back to Nick so he can be your favorite interrogator. Thanks.
Thanks, Linda. So yeah, we do have a huge line of questioning that we like to ask when we're talking to a client. It's really like, what are you expected to hand over to your client? What is the current state? How do you do things today? Do you walk around and field measure? Is there an opportunity for laser scanning to come into play? And then we look at, okay, yes, we do want to scan a building. What do we need to scan? Is it the site? Do we need to capture the roof? Do you need above ceiling spaces? Do we need to go in and out of every room? Really kind of identify the total scope of what it is that we need to scan. And then on the back end of that, it's what elements that we're scanning do we need to model, right? Because one of the beautiful things is we can scan everything and then just selectively model elements that matter to you. So we can go on site and capture the full scope of the building, and then maybe we just produce a shell and core model for you guys to take into the architectural design phase and use that as a basis of design for the building. But really our goal is to understand what it is you're looking to accomplish, and then we bridge that gap, right? Whether we sell you the hardware and teach you how to use it, or we come alongside and perform the work for you and produce those models on your behalf. It's really about understanding where you're trying to go, what you want to get to the client, and then obviously prioritizing and aligning on those objectives through that scoping process. To Linda's point, it's a lot of questions. We're going to ask you 50 million things. But the goal is really to make sure we aren't over scoping the project and we fully understand what it is you're looking to accomplish. So on the screen here, we're just going to click through a project that we did recently where we had to scan an auditorium. This is the point cloud data, and then you're going to see how we kind of fill that in with the model data. And the way it works really is very simple. We grab the point cloud data, we section it out, and we begin tracing over in Revit with all the architectural details, all the mechanical, electrical, plumbing details in the model. In this scenario, it's a very large historic building. The facade of this building was really old and unique. We had to build unique families for the windows and the facade details because that stuff didn't exist in any of our libraries. But that's a part of our solution, is understanding what details matter to you, what we need to model, what needs to be contained in there. So in this scenario, they needed everything on the interior, and we truly built an as-built representative of the existing conditions, all the chairs, all the seats, all the architectural details in the ceiling, so that as they begin remapping out the space and understanding how they want to repurpose it, they have a full picture of everything in that building, what it contains, and then the model associated with it to kind of take that into the next design phase. So this is just a really cool, fun project. One thing that's important is because we capture everything in 3D, it doesn't mean that we have to give you output in 3D, right? We have lots of clients who still work in 2D, so the need to produce 3D content and give them 2D content back that they can work with is absolutely a process that we go through. We're going to show you why this is super important, because a lot of times what we get in the as-built conditions are not representative of what's actually out in the field. So with that being said, we'll talk about the soft cost of project pursuits and visualizations. First, on the left here is our historic method of capturing, right? It's lots of photos, it's thousands of photos, and then it's 10 million handwritten notes on a piece of paper, right? I think that's been done for a really long time. We have teams that are really, really good at it, but the biggest challenge we see is piecing it all back together once you get in the office, understanding where that information is, and then inevitably making the trip back to the site to go capture the data again, because you always forget something. On the right is kind of that future state, right? We've scanned this building one time. We have a complete understanding of every point in the entire facility, and we went through and created a model from that. And we know it's right because we did it from the point cloud data. There's millimeters of accuracy in that when we go that route. Oftentimes we're uncovering issues in the building that maybe we didn't even know existed, right? The conference room wall is off from where it was supposed to be. The mechanical piping has sag in it. There's all kinds of things we can identify when we go through this process. The key here is we're capturing one time on site millions of points of data, and we're not relying on people to remember what they wrote down, what the photos were that they took, or what the heck it's related to. So I think the key driver here is that when we collect bad information in that project pursuit phase, the ramifications are not felt until we're all the way downstream, right? We build our design around it, we make bid decisions and cost decisions around bad information, And now suddenly we're in the project and it's like, hey, that ductwork is not where it's supposed to be. We did not measure that correctly. Now I got to file an RFI and I got to get the process going to resolve this design issue, all because we captured a bad measurement up front, or maybe didn't capture it at all. I think the latest industry standards say that the average RFI costs about $5,000, whether it has a project impact or not. So the administrative cost of managing an RFI is between $3,000 and $5,000, meaning every time we make a bad measurement up front, we're potentially costing $3,000 to $5,000 downstream on our project, simply because we have to ask a question to clarify something in the design. That being said, obviously hearing us talk about it over and over again is not that appealing. So we do have some comments from clients here. So one of our clients said the time spent to document existing conditions is hundreds of labor hours. It ties up our most senior people. They have a high billable rate and we have to send them back to the site over and over again. In this scenario, we can get on site one time, capture the entire space, and then you determine what's valuable to you from a modeling perspective, but you know that you have all the data that could possibly come from the site from your first visit. And that's where we see the real value coming on this side. The other part of this is not trying to figure out what that photo is, or which building is this from, or did anyone capture that detail, or do we know where that photo that we took is? Like, we lost the photo completely, right? In our scenario, we'll give you a little map. It'll say, here's every instance of where we scanned the building. And then you can jump into those in real time, pan around in a Google Street-like view and actually interact with the space, make comments, make notes, take measurements, and do all of that from your office. And we find that that workflow is simply, obviously, much better because it's a one trip out to the field, and then every team member downstream has access to everything that you captured while you're on site. And we're not relying on people to read through the hieroglyphic notes that we've taken while you're on site there. So here's a real world application of this where we've taken a space that was being remodeled. It was a simple adaptive reuse. We went in, we laser scanned the space. We gave the client this 3D photogrammetry so they could pan around and look at, measure, take off. And then what they did is use that to turn it into a design intent, right? So we took existing conditions, we gave them real world measurements, and then they turned that into a future state for the client to envision what that space will look like. And these can be interactive, they can have different design elements to them, but all of them are facilitated by that initial on-site capture, the ability to get more data while we're on site the first time, and then better output that information into design ideas that we know are probably based on real world conditions. So with that being said, Linda, do you want to talk about the idea of as-builts maybe or maybe not representing real world conditions?
Well, I think that we all know that as-builts typically do not, represent the real world conditions that we encounter. So again, I just think going back to that same point is the projects are based on time and proposals are based on time. Then we should utilize technology today to be in the best position to have a clear understanding of how much time we actually will need. So this is the store. This is, yeah. So this is the. I'm sorry, I've got like 3 things open on my screen.
Yeah.
So we actually had a client, and these were their as-builts. And so we went in and we scanned for them, and the exterior walls were located in the right place. Unfortunately, the corridors and the conference room, it was 16 inches, the wall was 16 inches into that conference room space, and the corridors were not, what they thought they would be. So clearly down the road, that would have complicated, ADA compliance issues and things of that nature as they continue to, expand this building through the project. And again, it's just the nature of the buildings, right? That they aren't representational of the documentation at the time of closeout. So it's a good starting point.
Yeah, and I think the bigger thing that we see here is oftentimes you can go in and take all these measurements, but you don't have any relevance in where they are in comparison to each other. So it's like, yeah, that wall is the right length, but is it set in the right place? Does it start the right way? Does it have an 89-degree angle to it, right? I think we kind of find that to be the bigger challenge.
Yeah, absolutely. Because you're right. That's a great point, right? You're absolutely right. When we measured the hallway from, wall to wall, that was the measurement. Unfortunately, the whole building was shifted over. So good point.
Yeah. Yeah, and I think we see this especially like in the like in a hotel space where you have one room that's reused 150 different times. If you
Right.
plan a design for a room and then you get into another version of that room where it's off by 6 inches to a foot, that can mess up your entire design application. So the benefit of getting in there and capturing this detail is obviously very important.
Or even as that relates to revenue, right? So we're doing a hotel, we're converting a hotel, we're changing brands, or it's a space that's been abandoned for a while. When we go in and we do those initial, that initial planning, right? And we're looking for revenue and how many rooms per floor. I was in a studio, we had a situation where they actually were able to create an additional room per floor, which generated, 11 more slots of revenue for the owner. So being able to bring that level of understanding of that building to your client is really what this is about, right? So good example.
Yeah, absolutely. And I think one of the references we have is, what's it take, about 90 seconds to capture a single scan location? Does that sound about right?
Yeah, so with photos, so it's 26 seconds. If you want to add a photo, it's another 60 seconds. So, and that's full color and HDR photography. So it's fast. And 2 million points per second. I don't care how good you are, how fast you measure, you're not measuring 2 million points per second, right?
Yeah, right. And so that's the real benefit. We can take 90 seconds and capture 52 million points of data and 180 plus high-res photos that can be stitched together into photogrammetry. Or you can take 90 seconds and have your person potentially go measure something, maybe correctly, incorrectly, get the right detail. We don't know, but that's going to take tons of time to do. And in the same amount of time, I think we can capture significantly more data. Absolutely.
Yeah.
So next, how to minimize RFIs and easily share site-related info with stakeholders. This is a cool topic. I think we're going to show some software here that really addresses some unique problems. Take it away, Linda.
Well, I think that that's something that we always think about, that we don't necessarily talk about, and that is, how do we use laser scanning throughout our entire project, right? Everybody always thinks, oh, well, it's existing conditions. And I always say, even if it's green field, there's still roads and telephone poles and things that are overhead and adjacent buildings. And there's other things that are relevant to those, existing conditions if it's not essentially a building. And to wait on, Google Maps isn't great. To wait on the survey typically puts you behind in your schedule. So you have all the front end stuff. We just helped a client win a really, really big deal by utilizing that information in the context the architect dropped in the building, and they took the owners through the entire visualization process. It was very competitive, and they beat out 7 other firms to win that work. So, it's certainly relevant, on the front end in the pursuit, the value. Obviously, as we move through the process, I know everybody has to go do, site visits and project walks, and they walk through, and sometimes they get, photographs or things of that nature, but they're not related to the building. RFIs are a great example. If you, scan your work as you're going through from the GC side, even from the from the architecture side as well, like everybody's on the same page with, accurate information. So there's some really amazing ways to use the data in regards to analysis. Is that where we're headed?
Absolutely, yeah. So the problem obviously is kind of missing this data in the field. A lot of people spot check 5 to 10% of the total work with the total station. So the vast majority of the mistakes that happen are completely unchecked. And more importantly, we don't have a real good picture of whether my as-builts actually represent the existing conditions. So to Linda's point, this is where the reality capture comes in and becomes a super powerful part of the workflow. And then what we're going to talk about next is kind of the ability to use some software with that to actually make the analysis super simple. So I'll go ahead and click play here. Delinda, do you want to talk us through what's happening?
Yeah, so this is just a simple tool to do an easy analysis. You can check your design against your current, existing conditions. So there's a lot of automation here. This used to take, a tremendous amount of time. And so now by utilizing the point cloud data and the design model, you can run them together, and you can run it in a few minutes. It doesn't take, weeks and weeks to do these checks.
Yeah, and in this scenario, I think it's actually spitting out like a progress monitoring in real time, showing us what's installed versus not installed. And what they just did is set a tolerance that says, show me everywhere that we have content that is out of a certain tolerance that I've specified. And you can do that by item set or work type. So in this scenario, this is showing a plumbing discrepancy where this plumbing line was installed, but potentially installed out of tolerance.
Correct.
And then the next one is the QA tools. What's up with this one?
So this is gives you the ability to do the QA QC to what's being built in regards to what's being what's with design versus what's actually being built in the field. So the elements, deviations, again, reporting. You can get your entire project in a fraction of the time versus all these manual spot checks. So it allows you to have that overview in regards to your project status. So this is heat mapping I have in here, can show that as designed in regards to the as built modeling. And again, it's all about getting in front of these problems, right? We're so reactive as an industry. The majority of our time is spent reacting, and the tools are available today, whether you want to do them yourself or you want us to engage and do it with you or do it for you, then let's turn into a proactive approach versus our reactive approach.
Yeah, absolutely. We're kind of tackling these problems in real time until we jump into the next. We're getting ahead of it instead of us getting the tenant improvement call and us jumping in and realizing that the as-builts we provided were not accurate. We're making sure the accurate nature of those as-builts before we ever send them over. And I think that's this last piece here is, one second here. I just clicked, there we go, updating the as-builts. So I'll click play here on this one.
Yeah, so again, this is one of the same software platforms. I think everybody's probably super familiar with Navisworks. This actually runs inside of Navisworks. So to capture the accurate documentation, so you're as-builting as you go along. Again, coordination, communication, proactive. This is not, vaporware. I mean, this is absolutely viable, strong software that brings a lot of value.
Yeah, and I think the real benefit here is it's taking the point cloud data, we're comparing it where it's out of tolerance, and then it's actually pushing the updates of the real world conditions back into the Navis model. So the kind of manual drag and drop of the Navis model where you've had to manually adjust things based on the field verification, all of that can now be automated, to Linda's point, through the plugin, make it super simple for you to jump in and actually take the functioning content in that model and make it easier to interact with. Okay, let's jump to the next topic here. So that's, how do we overcome talent and labor shortage in today's market conditions? And so this topic is a very broad one. We've tried to be very succinct in our approach. What we found and what Forbes is kind of telling everybody is that the idea of keeping employees in their best and most appropriate roles helps manage the cost, deliver shorter project life cycles, and enables your firm to take on more work without putting this massive burden on your existing employees to do stuff that they probably don't love doing, right? And so I think across the industry, we're seeing very, very healthy growth, and we're seeing lots and lots of people being able to take on more projects than they have historically. But the one challenge is cool, we can't hire anybody. We don't really want to have to scale up our teams, or we can't even find people that are applying for the positions. So, what we're seeing is an increase in demand of people asking companies like ourselves to help them out, right? And whether we do that in a fixed fee contract or we do that via time and materials or on a subscription, really our model is meant to allow you guys to kind of help plug people into your projects in whatever way is easiest for your team. And in our mind, taking a design professional, an engineering professional that works with lots and lots of other clients and applying them to your team gives you some good insight in terms of what other people in the market are doing, how they're tackling problems. And more importantly, it prevents you from having to hire, train, and get a person up and running for a single project when potentially at the end of that project, there might not be corollary work downstream for that person to work on. So that scalability of your team is obviously a little bit better. The way we do that is we actually have 3 teams in-house. We have a Salt Lake City team that is focused on high LOD modeling, specifically in the MEP space. We do lots of fabrication, lots of spooling, lots of real-world condition modeling and coordination. We have a Hawaii team that does all kinds of modeling. They're mostly focused on architectural structural, and they really focus on coordination efforts and high-level modeling with an architectural background and a focus there. And then out of Argentina, we have a partner firm with over 160 people. There we kind of have a pool of people with all different skill sets. And really our goal is to look at your project requirements, figure out what it is that you need, what kind of talent that you require, and then pull from the right pool of people available to make sure that we're tackling your project in a kind of cohesive and concise manner. So with that being said, how does it work? We try to make it really simple, right? You guys let us know that you have a project. We'll work with you guys to create a quote. When you say, hey, it's time to go, we'll actually assign a PM, someone oversees the project on your behalf. We work with you to kind of work through this process of developing model content, getting a scope defined, building out the scanning on site, and then modeling all that content. Whatever the scope of work is, we'll kind of tackle that with you up front. And then we run through this work process with you. Along the way, we want to meet, right? We want to meet once a week or once every day, depending on the type of work we're doing. Make sure that we're doing things the way you want us to. We're using your Revit template, we're following your standards. And then we have this QA/QC process at the end with the lessons learned. Final submittal comes into you guys. It's just a way for you to expand your team and your capabilities without having to add headcount necessarily. And again, we do that with the laser scanning, we do that with the modeling, we can do that with just a general drafting if you're still working in 2D. So with that being said, obviously we've covered a lot of topics today in a short amount of time. We wanted to open up a Q&A period. Did anyone have any questions for Linda or myself related to what we've talked about here and the reasons why you might want to tackle Scan to BIM as part of your process? Let's see, oh, I got one here. What process do you use for adjusting the as-built model? Let's see here. What process do you use to adjust the as-built model created from the point clouds to a reasonable standards? In other words, walls at a corner may be 89 degrees, but no Revit user wants a model that literal. So we typically will create a modeling standard with our clients when we're doing the as-built condition capture. We ask you guys, hey, do you want walls represented as is, or do you want us to take them within a construction tolerance? So we do find that, the walls tend to drift a little bit across the corridor. That doesn't help you from a design perspective. Knowing that the wall is 89 degrees doesn't help you from a design perspective. So typically, at your request, we'll actually square up those items. We'll say, hey, here's the average point in which this wall crosses. We're going to square everything up to that item. Because to your point, no Revit user is going to benefit from an 89-degree wall, and trying to plan a design around that would be a nightmare. So we do absolutely kind of take your preferences and let you guide us in terms of what those tolerances may be, and then modify or accommodate that model to those standards based on your needs. Hopefully that answers the question.
Absolutely. But knowing that the wall is 18 inches off from where you thought it was is going to be that value to your designer.
Absolutely. Yeah. So there's a ton of benefit in knowing that it's off, but to your point, knowing exactly how many degrees off is probably not beneficial. So we do try to use some reasonable constraint there.
Certainly.
I think that's the only question we have right now, and I don't see any others popping in. So I guess with that being said, Linda, we can call it a wrap here today.
All right.
Any
Well, thank you
comments?
for joining us, and reach out. We're happy to help.
Appreciate everyone's time today. Try not to work too hard if you can avoid it. And please let us know if any questions pop up that you didn't think about during the presentation today. Thank you so much, everybody.
Thank you.